So like the alkanes, let's start easy with the alkenes and just deal with linear change. Now, the big thing that's going to change with the alkenes is that we do have to designate the position of the double bond, and we're going to do it the same way we did with designating the positions of branch groups on alkanes, is that we want to minimize the number. So here I have hexene in all three. So we've got our long carbon chain, and the E ending here is going to let us know that this is an alkene. Now, every single one of them starts with hexene, but the question is, how do we designate where our double bond is? So in this case, it's easy. It's on the first carbon. So we're going to say that this is 1 hexene. This one's easy. 1, 2, 2 hexene. 3, 1, 2, 3, 3 hexene. Well, what about here? Will we designate this as 4 hexene? The answer is no. And the reason we wouldn't designate with hexene is that if we start this as the primary carbon, 1, 2, 3, 4, we would end up with a 4 position. If we do it here, 1, 2, this ends up being 2 hexene, and this would end up being 1 hexene. So you need to be judicious in where you're assigning the primary carbon for naming hexenes, because you want to minimize the number like you do with any group. Now, the trick here is recognizing the symmetry. If we rotate around this carbon single bond here, if we rotate this around, we recover this formula. We'll recover this around, we recover this formula. If we rotate this one, it doesn't matter. There's symmetry through that double bond, so we'd always end up with 3. So if you can't see it in terms of the geometry, recognizing that this is just that compound spun around and flipped, then recognize it by numbering the carbons. If we start here with this as the primary carbon, this would have ended up with a 4. If we start here with a primary carbon, this would have ended up with a 2. And that's how you name really simple alkenes. Now, next video, how we start naming it with more things attached to it.